Hello and welcome to this brief tutorial on presence fields and how to generate them. This is the second video in the series and will be covering the basics of navigating the Grasshopper scripting environment and how to export an image from Rhino. In addition to this video, there is one other that outlines the theoretical framework that defines a presence field and the purpose of the components that we will be manipulating. All links are in the description. Getting right into it, here we have a fully rendered presence field with some 30 individuals represented. To generate this presence field, we must first start from the 3D model. Open the Rhino file that is provided with this video and type Grasshopper into the command line to open the Grasshopper scripting window. Once the window is open, you will need to open the companion Grasshopper script. I have named it the same as the 3D model for consistency. Once the script is loaded, you will notice the presence field rigs highlighted with red outlines. This means that Grasshopper has identified them within the model and has drawn their outlining geometry in Grasshopper space. Note that Grasshopper space is different than Rhino space and only references the presence of potential geometries. Before the presence field can be rendered, the rig geometries must be baked. More on that later. These geometries and their respective light objects make up all of the components that are necessary to render a presence field. And while the Grasshopper portion of this workflow remains important, the components can be arranged manually in Rhino space if desired. Just be sure that the projection box is checked if you choose to go this route, so as to avoid moving the rigs off of the host surface. I don't particularly encourage manual arrangement, but let's take a few moments to further talk about the role of the geometries and light objects regardless. I spent some time in the last video discussing the different components of the presence field rigs, but now we will take a look at how they function in their native program setting. The basic rig is made up of 3 primary parts, each with their respective geometry and light objects. The first part is the head and shoulder geometries and accompanying point light. These components work together to generate the head and shoulder silhouettes, and to display the direction of the gaze and orientation of the shoulders from above. It is the only part of the rig that does not cast light on the larger projection surface, instead limiting its illumination to the interior of the shoulder cavity. The second part is the shoulder projection light and reflecting surface. This includes the wider of the 2 surface lights and the outer curved shell that is positioned at its edges. The shoulder light should generally be the dimmer of the 2 surface lights, but should illuminate a broader surface as it is positioned at the leading edge of the shell. It is also higher above the ground plane to further diffuse the light that it casts. The third and final part is the head projection light and reflecting surface. This includes the narrower of the 2 surface lights, and the inner curved shell that is positioned within the larger shell. The headlight is typically the brighter of the 2 lights, and makes up for its narrowness by having a higher luminosity and extending all the way to the ground plane. It is also set back slightly to produce a sharper, more focused light. Before we get too invested in finalizing our geometries, let's take a step back and look at the Grasshopper script. Every script should have an organization structure, just as every Rhino file should be organized by layers. This can be achieved in 2 ways, and works best when both are used in tandem. The first way is by organizing components so that their relation to each other are intelligible. The organization of this script's components is shown here. The second way to keep your script organized is by keeping collections of components that work together in groups. You can group components by selecting them, clicking the middle mouse button, and clicking the group icon. Once the group is made, it is best practice to label it accordingly. You can do this by right-clicking the group and typing a label into the box at the top of the drop-down window. You can refer to the groups and overall layout to quickly navigate the file and change values where necessary. The matrix-like organization assists in this, and can help you find the particular rig that you are working with in Rhino space. Just use the number that marks each rig and cross-reference with the respective location of the script for that component. You can change the orientation of the shoulders and head by adjusting the sliders designated as such. The rotation of the head is also controlled by the shoulder rotation, but can be independently adjusted by using its own slider. In this way, you can finally direct the orientation of both the head and shoulders until the presence field is tuned to your liking. You can even go as far as determining the height of the rig and the intensity of the lights. To adjust the location of each of the rigs, you must first adjust their respective MD slider, which is positioned with respect to the rig's naming convention above. These sliders each reference the same plane in Rhino space and orient their respective rig on the point designated on the slider. The size and shape of the plane can be altered as desired, or you can split multiple rigs between multiple planes. You just need to change the input that the slider is referencing. I have found that the larger the plane, the more difficult it is to finally position the rigs, but you can usually manage by zooming in for finer adjustments until you've dialed it in. After going over the various portions of the script, you may notice some redundancy in how it is structured. For instance, this is the same file, but for only a single presence field. The organization of its parts is very similar, but with only one instance rather than 30. The 30 rig script would normally be consolidated into fewer parts for efficiency, but the current stumbling block is that Grasshopper lacks support for native light objects, so the rigs must be separated into individual instances. Unfortunately, this puts an upward limit on the number of rigs that can be processed at one time, and therefore limits the scale of rendered files to a couple hundred instances at most. Another consequence is that the lights in the model must be locally defined in Rhino, and can only be referenced with guide containers in Grasshopper. This makes it difficult to add additional rigs to the model due to the fact that duplicate instances will disassociate the light objects from previous rigs and reorient them to whichever one was active last. In order to get around this, every time a new rig is generated, the user must associate a new set of light objects with it. I have left a few duplicate lights off to the side in the Rhino model for this purpose, but my advice to casual users is to start with a file that has more rigs than you need, and simply move the ones that you are not using to the edge of the workspace, or even delete them. You can always add more, it is just easier to start with more than you need. The light IDs that need to be replaced when creating new rigs are located in the lower left of the script block, with the shoulder light being the top guide, the headlight being the middle guide, and the point light being the bottom guide. You must right-click the guide container and then select the appropriate light object in the Rhino model to set each. With this last caveat taken care of, I will quickly time-lapse the arrangement of the rigs using all of the mechanisms we have discussed so far. Now, with all of our rigs in place and their presence fields finely tuned, all that is left is to export the final rendered presence field. There are a few steps to this part as well. We must first bake the grouped brep containers that are located in the lower left corner of the script. These containers hold the final geometries of the rigs and need to be brought into Rhino space before the field can be properly rendered. When using the middle mouse button menu to bake, the geometries will populate to whichever your active layer is in the Rhino model. Just double-click to change your active layer. Additionally, the material of the rigs as assigned through the Rhino Layer tab can have an effect on how the rig interacts with the lights. Feel free to experiment with different materials, but I find that the default Rhino material works pretty well. Once baked, the final step is to render the view from the top viewport in the Rhino model. This can be done with whichever renderer you choose, but I will demonstrate using the default. And there you have it, a fully rendered presence field from start to finish. Exporting from Rhino is pretty straightforward. Just click on the save icon and select your file format. If you are just testing your view and don't wish to fully render yet, I recommend using the render preview instead of the final render option. And if you find that your render produces sharp edges, finishes quickly, and has less definition, sometimes it is necessary to save the file and reopen just the Rhino portion before rendering. This has been a consistent problem for older versions of Rhino. I hope that this has been a helpful and informative demonstration, and if you haven't caught it already, I once again recommend the Introduction to Presence Field companion video. There, I go into more detail about the supporting theory behind the research, as well as give an explanation of what all of this represents. If you enjoyed this discussion or have any suggestions, please leave a like and comment below. If you're interested in seeing more videos like this one, please consider subscribing and enabling the notification bell. Until then, until next time, this is Harrison Marek with Interval Design. All citations, as well as the links to the files used in this demonstration, are located in the description.